Hi, I'm Michael White. I'm an employee with Entrance Software, and I oversee all the application development for the company. So anything that happens from a custom application development side is under my responsibility. And I work with a wonderful team of developers to ensure that it's done properly and with the best value for our customers. Today I'm going to be talking about how software ages. You know, it's an interesting concept. You know, we don't think about software as something that can age. You know, it's code that's written and run on a computer. So it doesn't age like hardware does or like people do or anything else. It ages in a way that it becomes obsolete or becomes less functional, unable to keep up with the demands of the business users and things like that. You think about software as written typically based on a snapshot of a business need for a certain period of time or a certain range of time. However, the software doesn't change dynamically like the business does. Businesses can change, market demands can change, the size and number of users in the user base can change, and the software oftentimes has difficulty keeping up with that. And that's one aspect of aging. Another aspect of aging is that the software may have been built in a technology that's no longer supported, or it's slowly on its way out the door. It's being deprecated or replaced by more modern design patterns or technologies, right? So that software may have been written some time ago, and those resources are no longer available or very difficult to find. And when you can find them, they're very expensive, making it even more costly to try and maintain this software. Other ways that software can age is that the technologies and design patterns and understanding of software as a functional piece of a business were limited 10, 15 years ago, and that technology continues to evolve. We think about legacy applications. They were monolithic in nature. They were written top to bottom. Every line of code was executed in one lump sum. And so if you had to change one little thing, you basically had to change the entire application. Well, nowadays we have better paradigms, better technologies where we can separate out the different pieces of concerns within the application into multiple layers. So we can have part of the application that's written to manage just a database. We can have another piece that manages as business rules and validation. We can have another piece that's a service layer that allows for integration of other systems and other software into the mix, and still be able to reuse some of the code that's been already written for business logic in the database. And then, of course, the front end of the application is changing. It used to be all just PC-based, but now we've got to deal with additional form factors like tablets and cell phones and other devices so that people have access to your software anywhere in the world. So looking at that, we can begin to realize that there is an aging process that happens with software, and as it ages, it becomes more difficult to maintain, more expensive to maintain. And you can even look at hardware, hardware that you can buy today that has multiple core processors in it and robust memory capabilities. The software that was written 10, 15 years ago wasn't designed to take advantage of those hardware capabilities that are available today. So you may have a significant investment in new hardware for your company, but the software can't take advantage of it. So you have some lost opportunity with that disconnect with the capabilities of the software and the hardware you have. So bringing that software up to date will allow you to take better advantage of that and give you better economic scale for your software.